Raina is honestly one of my favorite speakers. I just really enjoy, he's such a good, clear teacher, and he just makes things so understandable. But he has really developed this talent. He works with a group in his country, Austria, and it's called Angular Architects. He does a lot of training and consulting there, a lot of workshops. I definitely encourage you to sign up. Go check out their Angular Architects website. He does some in English, so very accessible to you there. But he's an Angular GDE. And then something else he does that I really love is his weekly videos on YouTube. It's called NG News. So he's always giving updates and just kind of keeping you in the loop with the latest and greatest and all the stuff you want to know that's going on with Angular. So check that out as well. But yeah, thank you, Raina, for coming. We're so grateful.
Yeah. Thanks also for the nice introduction. So I don't need to
Definitely.
say anything about me anymore. And I would say we'll just get to it. Again, very happy, very honored to be here as well. I'm part of the DevFest. In the next hour, the plan is that we are going through unit testing. From the agenda, I would like to start with the core concepts, which means it's going to be very theoretical. I'm trying to keep it short. And the rest, the mocking, the way how we can manage asynchronous tasks, and then also how we can deal with fakes, or what benefits fakes provide us and what they are. This is then something which I want to do mostly with just coding the thing. So I have also prepared here an example for that. Let's start with the basics. So first of all, maybe before we even start with the theory, I think Brooke and we had a chat yesterday about the way how we want to deal when questions coming up. So I said if there is some kind of question in the chat, then Brooke can just interrupt me and I'll try to answer it. So feel free to ask at any time. Core concepts. What is a unit test? Let's start with that one. So there are, unfortunately, and I always have to say it, unfortunately, we don't have a global definition for these kind of testing types. That's why I always start with introducing the term unit test. And as we see here, we have here an Angular application, we have a component, which probably is the central element all the time. And if I say I want to write a unit test, then what I mean is that I say I only want to focus on the class, on the TypeScript class. I avoid actually testing the template, and I'm also avoiding to use any of the dependencies. Dependencies coming from the dependency injection, obviously, but also from the template. So it's only the TypeScript class and nothing else. And as a matter of fact, and I will cover that in the upcoming slides, the question now is now a unit test a perfect fit for a component, or should we more look to other things where unit tests are better suited for? Will come later. From the toolings perspective, there have also some changes, or some changes happened last year actually. We know if we're using the Angular CLI, the tooling that we're using is Jasmine and Karma, whereas Jasmine kind of provides the API, provides the commands that we use when we write a test. And it's accompanied by Karma, which takes these tests and executes them inside of the browser. That's the default technology, that's the default tooling that we have. Karma at the moment, Jasmine Karma is still the one that we get when we are initializing a new Angular project, but we also know that the lifetime of Karma is limited. It's already kind of deprecated, and we are waiting for its successor, which will be the modern web test runner. Has already been announced, I think, 2 years ago. We still don't have it, but the Angular team says, first of all, it's not so urgent because Karma is still working. It's not like there is an emergency that we immediately have to replace it. And there have also been some other priorities going on, but this year, and especially for Angular 20, they have some plans to improve testing. Then we have Jest as the long-term counterpart or alternative to Jasmine Karma. Jest does not require a browser because it's emulating the browser, and Jest is the tooling that you always by default get when you're using an X instead of the Angular CLI. There are some plans, officially, there are some plans that Angular wants to introduce or bring in support for Jest as well into the Angular CLI, which would be a big benefit because we are struggling with some performance issues, especially in the build process when it comes to Jest. And if Angular would support Jest, then these problems are just gone. And since last week, we know that there is a PR where there is also now an official, although limited, support for V-test, which many see as the modern testing framework to use. And we don't know so much about it yet. So there was always this discussion in Angular. We know that we want to go with Jest, but maybe not. Maybe we want to go with V-test. We didn't really make a decision so far. And now we have a PR for V-test, which at least looks like they are seriously considering to use V-test, hopefully instead of Jest. So my personal opinion, I will go with V-test because it's just a more modern one. In this workshop or in this talk, we are going to use, I'm going to use Jasmine, but I also have slides where you see the differences when it comes to Jest. So especially when we are doing then the mocking part, the commands in Jest are a little bit different. I have prepared the slides, but in the coding, I'm going to use only Jasmine. What about V-test? V-test promises 100% compatibility with Jest code, which means whatever you have written in Jest will also work in V-test. I can, and I know this by I have already seen that this is really the case. I'm also part of ng-x, of the ng-x team, and we have migrated from Jest to V-test in the last couple of months, and that was quite successful and without any big troubles. Good. Maybe also a little bit about the download statistics. So you see here, Jest is still number one in orange color. Red color is V-test, very young compared to the other ones. And we also see here it is catching up. It has already kind of overtaken Jest and Mocha, and also, of course, Jasmine. And it's, I would say now, the main competitor, the upcoming competitor for Jest. And because we are talking about testing, maybe just to complete the whole picture of the tooling, I also have here the download statistics for the common end-to-end frameworks. We see here Cypress, Playwright are also this pair which most of us are using. And since last year, one could say that Playwright took over the first place. Good. That's it about the tooling. And now about pros and cons on unit testing before we then really dive into it. So when we are writing unit tests, you have seen it's just the TypeScript class and nothing else. That's the fastest type of test that we can get. It doesn't become any faster. We can also use these tests for exploring stuff. So because I have control over all the dependencies, I can mock them, I can fake them, however, in whichever way I want. I can try out very, I would say, edge cases, and I can really try out how my kind of class under test behaves. Because classes usually are not that large, whenever a unit test fails, it's also very easy to spot where the bug is. It's probably in the component. And given that the component doesn't have 2,000 lines of code, it should be easy to find the source of the problem. And this is kind of from personal experience, I would say, if you're writing unit tests, especially if you're doing test-driven development, then you will see that your code becomes very, very good design. It's very easy to use because you're always the first consumer of the code that you have written. So you always try that it's very usable in that sense. You're trying to avoid to add too many dependencies to a class because you have to mock all of them. You try to keep the class short. You try to keep the functions, the methods very, very readable and that stuff. And that really pays off. But there are, of course, also then downsides. And the first or the main one, which we very often hear, is this refactoring issue. If we say we have a component or a service, whatever, and we have a unit test for that specific class. If I If I'm going to now apply refactoring, which means that to the outside, to my end users, the application stays exactly the same. But let's just say I now decide to split up a service into three different parts, three different classes, then I already have a problem with my unit test because now my unit test also has to follow this refactoring. That means I have to change my unit tests because otherwise they're not going to work anymore. And that's already the problem. Because the basic idea would have been that if I have some tests, that I can do a refactoring. And if my application doesn't change, then I don't need to touch my tests and they will give me the guarantee that the behavior is still the same. With unit tests, I'm losing this kind of possibility. That's one of the main downsides. High maintainability, yeah, it always, of course, it depends. But because I always have to refactor the test as well, that means that I also have to spend a lot of time when it comes to refactoring tests. And this is now a comparison to the other testing types which we have, for example, integration test, for example, end-to-end tests, where we're covering much more than just one class. We obviously have to say, yes, one single unit test does not have that coverage as a complete end-to-end test. And the same is then also true very often for the confidence. So if we, for example, have an end-to-end test, which opens our application, which navigates through some certain things, then I would say again, from a single end-to-end test, my confidence is much higher than from a single unit test where I'm just testing one particular class. I mentioned before this use case or this question with the components, applying unit tests to components. Yes and no. There used to be many years ago, it was quite common that we instantiated our classes on our own, our components. So by saying new component, whatever, we also kind of tried to interact with our components by calling methods, by asserting against properties, which would be a typical use case for a unit test. But over time, we reached a consensus where we said when it comes more to component testing or just testing in general, we have to be careful of not overdoing unit tests. It always depends on the nature of the application that you have. If your application has not so much logic and you have only components which are fetching data, showing them and sending it back, then very often a unit test might be a little bit too much. It might be better if you then would focus your strength more on writing higher level tests and keep the time for your unit tests then more for places where, say, here I have a logic, a very complicated use case. Here I have, for example, some edge cases which I cannot cover with integration tests and so on and so forth. So we see this that, for example, the testing pyramid has then also switched a little bit to different models. The one that I've picked here is from Kent Dodd's The Testing Pyramid, where we're saying if you start testing, then probably integration tests, so tests which contain more components, is probably the better start. And when it comes to unit testing, then you keep them for testing your logic, which would also mean, if we are thinking it through, that unit tests are made a perfect fit when it comes, for example, to services. This is where they really shine. This is where we have the logic. So whenever logic is important, this is where unit tests are also important. And we should also not forget one thing, because otherwise you could not say, okay, if unit tests are not so important, then why should I stay here? Just leave. There is one important thing. Unit tests come with fundamental concepts that you also have to use in integration tests. So it's not like you have different testing techniques, the way how you write your code. In unit tests, you learn how to manage asynchronous tasks and also how you mock dependencies. That is very important. This is something you have in unit tests, and you have to use it in the other testing types, component integration tests as well. What we have then in the higher testing types, they are becoming a little bit harder because we also have then the change detection. We also have then the complete interaction with the DOM. With unit tests, we are focusing more on the asynchronous level and on the mocking part. Good. That was it for the core concepts. And if there are no questions,
Angular test that test code plus template, do you consider it a unit or a component test? Great question.
So whenever the template is included and I'm communicating via the template, via the DOM with my component, then I would call this as a component test. As I showed it before in the slides, unit test is only the TypeScript class and nothing else. So mocking. Mocking is actually the wrong term already. Start already wrong. We usually say when we're writing unit test, we need to replace these dependencies, and the real generic term for replacing a dependency is a test double. The mock is a very specific type. I have listed here 3 ones which are very common. So we have, for example, a stub where we are providing some kind of alternative service in that case, which has a predefined behavior. But the problem with the stub is that we never can go to the stub after the test and ask the stub, hey, how have you been used? With which parameters have you been called? This is something which we get from a mock. We see here from in the mock, there is this jest.fn notation. This is the command that we use if you're using Jest. Same is then also true in vtest. And with the mock, we have the possibility also to go to the service and say, hey, how often have you been called? With which parameters have you been called? And so on and so forth. The spy is a little bit different. The spy could be used like a mock, but the spy has something in it additionally. We can apply a spy to an existing implementation, which means if you would now say, I not want to write a unit test, but I want to cover more classes in one test, and I also want to be able to verify how the dependencies are used, how are they called, how often are they called, then this is what a spy can do. Spy just applies to a certain method. We can say the original should be executed, but we still have some kind of tracking going on, which we want to use later in the test. In Jasmine, the spy is also the mock. This is a little bit confusing, but that's just the way how it is. If you want to create a mock in Jasmine, then you say create spy, and in Jest it's called the mock. So I also have here different functions available. So we have the spy on, the create spy, and the create spy object. I'd say these are the 3 main functions which we get from Jasmine. And in Jest, it is just jest.fn. Cool. And here we have the spy in actions. And because I said I have prepared an example, I would say instead of looking at slides showing code, we just go directly to the code itself and see it there. So I have prepared an example only for this workshop here. Kind of it aligns a little bit itself to the Teenage Mutant Hero Turtles. As you know, they're living a little bit in the sewers. And what I've written here is a component, a sewer locator. When I click here on the button, the browser takes the location that I have and then goes to the OpenStreetMap API and it requests the sewers which are in my neighborhood. So if I do this, then you see it's also interactive. So I'm also using here leaflet. And the turtle that you see here, this is where I'm living. And then it shows me the next exits. So this is where the sewers are. At least this is where OpenStreetMap says these are the sewer locations in Vienna. I can assure you there are much, much more. They are just missing in the database that they have. Good. If we want to take a look at the code. So there we are. Then I have here my components. And as I said, component testing with unit test is not really a good thing, but I just want to show you what it is doing. It's kind of delegating the hard work, the important part into the sewer locator, which is then the service. And we will test only the sewer locator, but not the component. This would then be a different talk. If we're going now to the sewer locator service, we see it contains quite a lot. So it's not like it's just a single HTTP request. There is a lot of going on. First of all, we see here that we have something like a status. So I just call the variable status, where I said this is now of type resource status, which we have since Angular 19. Then we have here a value. you could in a way see this as a state, but I'm saying here, I want to save the current position where I am, the current location. Then I want to, when I'm done with my HTTP communication, then I want to save where the next location is, and then I want to have an overview of all the sewers which are in my neighborhood. And all of that is then triggered by set location. I'm getting here the latitude, the longitude, and then I'm constructing here some kind of query where I'm going to this overpass API, I'm going to request here some data for the sewers. The data comes back, I'm doing some calculations. So as I said, a little bit of logic is going on here. And if we now want to write a test for this class, what are the most important things that we need to know? First of all, the public method we want to test. There is, I would say, we are not testing the set location, but what we actually want to see, what we want to assert is the value, is the state. So I say I'm providing a latitude, a longitude, and then I would expect that sometime later the value here has changed in that signal, and I'm getting a current, I'm getting the minimum distance, and so on and so forth. This is what I would expect. Good. So I have already here prepared at least a testing file. There's not much in it, but at least something that Karma can already execute. So testing now is starting. I really like it that the background image of the app is also now in Karma. And yeah, you see I'm using here fit, which means I'm only want to focus on this particular test suite and not on the rest. If I want to test my service, I require an instance to that service, obviously. Now, as I said it before, for many years, the way how we did it is that, for example, we would have said, I have my sewer locator, and because it's just a simple TypeScript class, I'm going to instantiate it on my own, like calling it like this. And we also then provided the dependencies, which would have been the HTTP client in this case, in the constructor. Now, as you see, this code is valid. It looks like there are no parameters in the constructor because I'm using the inject function, which is already a problem because now I cannot instantiate it manually anymore. Now I need to do the instantiation, or I let Angular have to do the instantiation because I require the complete dependency injection. Some of us didn't really like this, didn't really like the inject function. One of the main arguments actually was the missing possibility in testing to instantiate those classes on our own. Because if I now run the test, if I save here the file and I just say, okay, please run the test again, then we're getting here now an error because now the inject function is obviously executed when the function is instantiated. And it says, no, I don't know what you want from me. You obviously want to have an HTTP client, but I'm running not in an injection context, which means I can't help you. So you have to find another way. You could now say, okay, then let's just use the constructor and everything's done. No, we know in Angular 20, the inject function will become the officially recommended way on how to do things. And this has already been communicated by the Angular team in the past that they said, whenever you write a test, the starting point, so nothing goes below it, but the starting point is always the test bed, which means we have at least a running dependency injection of Angular, even in a unit test. There is a GitHub issue where they're explaining the reasons about it and also quite a lot of text. So if you're interested in the details, I would recommend to read that one. To put it short, they said the most challenges in testing was always when people started to instantiate classes on their own, trying to work around the dependency injection and do things on their own, which are usually done by the Angular framework. So what I have to do in this case is that I have to say, okay, I want to inject now the sewer locator. I'm letting the testbed do this for me. And as you probably know, we are now getting the same error again. And the reason is that the sewer locator is or has a dependency to a service which is not provided in root. Otherwise, we would already have it. The HTTP client is something that needs to be provided explicitly. We do it in our application config. In the old days, standalone, you had the HTTP client module. Now with modern Angular, we have provide HTTP client. I'm not going to do this now. What I will do instead, because I'm writing a unit test, I'm going now to provide a mock for my HTTP client, which means I'm here in Jasmine. I just say I have an HTTP client. And the way how it works, the things that I provide to my dependency injection are always unknown. So what I can do here is that I say, okay, I'm only providing an object literal, which matches in a way the same method that my service is going to call. I know the service is going to call the post method, and that's why I'm only creating here an object literal, which has the post method. And I'm generating a mock for it. Again, in Jasmine, the mock is also called spy. And now I have full control over it. What I have to do next is that, of course, I need to tell the Angular's dependency injection that this HTTP client exists and that it should use it and not look for the original HTTP client. And the way how we do this is that we say configure testing module before we are doing the injection. We have here our providers, and I say, okay, you know what? I'm now going to override, I'm now going to provide the HTTP client, and I'm going to tell you whenever you want to inject that one, use the HTTP client that I've just created. I save it, the test reruns again, and this time we see it's kind of successful. Jasmine is complaining a little bit because it says there are no assertions in your tests. But yeah, at least for now, we know we are now able to instantiate the service with our mocked HTTP client. The first thing, which I probably want to test, is if the initial status is there. So what I would say, I have here my expect, and I'm now going to my sewer locator. And if you remember, there is here this status, which is initially idle. So, and I decided for whatever reason that I want to check that one. So we have here the sewers, which is this property. And that one has the status included. I call it, it is a signal, obviously. And then I can say, I would expect that you are a resource status of idle. And before I type in idle, I'm typing in something else, namely loading. Why do I do this? Because I want to see the test failing. I want to see that the test is telling me, no, it's not loading, it's idle. I want to have the confirmation from the test that it's testing and failing exactly for the assertions which I have here. It's not so much time, but it will save you a lot of time later because you always want to never trust your tests, to make it short. So it says here, no, that's not the one. It's actually idle. Then I say idle, and now I hope that the test is hopefully working. By the way, you have seen before that that these enums here are numbers, 0 and 2. That one is also going to change in Angular 20. From 20 on, the resource status will not be an enum, but a union type. So it's also then a little bit more readable. And we see then also a string. Good. Well, and the next step would then be to activate the service, to work with it. And the task of the service is to find the sewers in my location, which means I'm now setting the location. So in the application, it's usually done differently because it's accessing the browser. But here we're saying, no, the only thing that the service requires from an inputs perspective is the latitude and the longitude. So I see here 46 and 16, which is around in this area of Vienna. And this one is going to be an asynchronous task. That's why it's here underlined. I don't want to await anything because it returns a promise of void. And then I can rerun the test if I want. But I already know what's going to happen. Now a request should be sent out. And I would now expect that some way my HTTP client needs to respond, which is what I'm doing now. So I go to my HTTP client. I have my mock in the post method. And there I say end. That's at least in Jasmine. That's the way how we do it. And I want to return a value. For obvious reasons, I now need to know the type of the response. It's going to be an object literal with elements. So I say it's going to be an observable, which contains elements. And the elements is an array. Let's say we have found two sewers, where the first one, latitude, is again 46, longitude is 16.5, and then the other one is very far away, 17. Let's use something like this. The off, of course, also needs to be imported. I probably want to define the behavior before I'm doing my request. So I say here, before the HTTP client is called, this is what you should do. So I define here the behavior first, and then I say, and now I'm setting the location, and I hope that now the HTTP client is used. Which would mean, if everything goes right, that my status, let's go to the sewer locator, sewers, and let's just say there is a value in it. And you probably remember the value before. There are some properties included. So we have here the current, the min distance, the nearest, and the sewers. So I say here current is undefined. So I'm writing now on purpose the wrong data in it because it shouldn't be undefined anymore. We have just provided the position. Undefined. Then the minimum distance, let's say it's 0. The nearest is also an undefined. And then I have my sewers where I say they should be an empty list because there's nothing in them. This should not happen. Yeah. So I have just set the location. Something should already be there. But if I run it, the test is successful. And this is not what I actually wanted. And now we have the other problem. Or the other problem, first of all, we need to know what the reason is. If we go back to our code, then we see, yeah, so far so good. Set location is doing the triggering. It sets the resource, the status. Yeah, we could have checked that, but I didn't do it. And then we have here this tiny await. So this is then the time where asynchronous tasks are included and where we in our unit tests need to manage them. Because the unit tests is executed synchronously and it will just execute. And after the synchronous execution, the asynchronous tasks will start. So we have to find a way now that we can change the order. We need to tell the test, look, there is an asynchronous task. You need to run that right now. And for that, let me quickly go back to the slides. Not here. There we are. Asynchronous tasks. From Angular, we have the wait for async, we have the fake async functions available. Those are the ones where Angular always said, look, especially if you use fake async, you have full control over the time. You can do whatever you want. And well, the way how it works is that we put fake async on top of the test. And we get then the opportunity to use certain functions like a tick, like a flush microtasks, like flush, where we can really trigger asynchronous tasks synchronously. So again, we have full control over the asynchronous tasks. Wait for async is a little bit weaker, so to say, because with wait for async, we only get the guarantee that when the test ends, that all the asynchronous tasks have always ended, but we cannot trigger them. But in this case, I need to trigger them because I need to say, look, this HTTP request, this asynchronous task needs to run right now because I have to do some other stuff afterwards. I need to verify, I need to assert that the value is set correctly. So this is wait for async. Here, the way how it works, as I said before, just the function on top of the test. And this is then fake async, the powerful one, where we have then flush microtasks, and other stuff. Let's go back. So let me just say here, I want to use now the fake async because it's the most powerful one. So I say here fake async, like this. Good. And then I need to tell when the asynchronous tasks should be executed. And in my case, that would be after I'm setting the location. So I would say here, tick. Just say here, tick, which means run all the asynchronous tasks right now, really blocking, really synchronously. And then this source, the value of the source, should not be empty anymore or should have the default value. Now I'm expecting that values are there. And because of that, my test is supposed to fail, which it does.
Let's
So we
see.
see here it says current, there is an object, latitude 46, 16, exactly what I actually have provided. I didn't do the calculation of the distance. Yeah, but this is probably done correctly. And what I have to do now, well, now I can provide the real values as I want them. So I would say here in current, let me quickly copy it. This should be done very quickly. So we had here 16. The minimum distance is 38664. The nearest ones are, 40, I think the nearest one is only one, which is hopefully that one, because the other one is too far away, I would say. So 47, 17. I don't even know where 17 is, but somewhere in North Germany, probably even in Sweden. You can look it up.
Probably,
Right.
yes. We
Well,
actually got a question. I just wanted to quickly
sure.
ask. George said, does fake async depend on Zone.js? And
Yeah.
if yes, is there an alternative for zoneless apps? Great question.
Yes, that's actually what I wanted to show you now. Yes, it's a perfect
Perfect.
transition to
Transition.
the next
Yes.
part. Yeah, wonderful, wonderful.
Nice.
Yeah. Yeah, so as you probably know, again, with Angular 20, we will see a switch, or not a switch. Switch, it's not a switch, forget that. But the zoneless support will become developer preview. So they're switching that from experimental to developer preview. And for obvious reasons, you should not really start to think about it. And if I say I don't want to use Zone.js anymore, then I would do it like this. So I would provide here in my test experimental zoneless change detection. I'm still running on 19. I think in 20, the term experimental goes away, but we see nothing has really changed. Everything is exactly the same. What we don't see, if we go into the console, then someone is already complaining and saying, hey, look, you just told me that you don't want to use Zone.js, but it's still there. Maybe you want to remove Zone.js from the Angular JSON and restart the test. So this is what I'm going to do now. I'm going to my Angular JSON. Now we have already here the polyfills. So I'm just going to remove the complete line. This is where Zone.js was actually loaded. And then I say I want to restart the test. And now it's becoming interesting because wait for async and fake async are both functions which depend on the existence of Zone.js. And now it's not working anymore. Now, the question, I think, the first question is probably, okay, is then there a zoneless fake async or something like this? No, which could be a surprise for some of us because, especially for me, I was expecting that we're getting something. Instead, the recommendation is to look somewhere else for these kind of helper functions. And the testing libraries, the testing frameworks that we are using provide that already. So let me quickly try to go over to the slides again, share my screen again. And if it comes to Jest, now I'm going to show Jasmine, of course. Jest, in terms of providing utilities for managing time, is a little bit better than Jasmine. We have here in Jest, they call it the fake timers. So before a test starts, you say use fake timers. Careful. What they are doing, and this is very important, this is also why I see it here on the right side. The fake timers are mocking, which means you could theoretically also do this on your own, but they are mocking the common timing functions, like I said, timeouts and interval and other stuff. They are just mocked by the framework for you. That also means that things which you cannot mock can't be mocked. Yeah, obviously. And the interesting thing is the promise is a native element of JavaScript, and that one cannot be mocked, which means whenever you have something in your test where an asynchronous task, which depends or which was created, which is a promise, those fake timers, and in Jasmine they call it clock, they will not help you because they say, I can't mock the promise. Which obviously now means, yeah, nice, but we have seen in fake async it was all working. Why can't the testing frameworks do this for us? Yeah, the reason is that Angular always avoided compilation to promises. So this was one of the main reasons why we have now Zoneless. What Angular has been doing all the time is that they said, look, we can't use a promise because then we cannot mock promises in order to let us know that a change detection is necessary. And that's why we don't compile promises natively, but we use an alternative which we can mock. Until now, whenever we are using Zoneless, in our browser, we have never used a native promise. This is going to change in Angular 20 when we are using Zoneless, or when you are enabling Zoneless. Now, because of that, Jest provides you with very special commands like run all timers or run tick or run pending timers, advanced timers. There are alternatives which have the suffix async. And all these functions, what they have in common is that they are running internally a promise that you can await in your test, which means the promise from your application code is of course queued before the test starts. The test starts, it queues another promise, and you are waiting for the test promise. But the test promise only runs if the application promise has ended. And that's the trick. This is the way how you can then enforce a waiting mechanism on a native promise. Now I'm going to show you now what this actually means or how this looks like. It's actually very simple, but I just wanted to explain it, what's going on under the hoods. So again, fake async is not going to work. I need to remove it. And in our case, we don't have a timeout. Yeah, we don't have a timeout, we don't have an interval, or we don't have anything which would in a way kind of trigger a macro task. We only have a promise, which makes it extremely easy for our test because I just need to come up with another promise in my test and need to wait for it. And then I also cover here this promise here again. The way how I do it, very simple. I just say here async. Then I'm looking for the location where the asynchronous task should be executed, which is right here. And then I can say await. The most easiest way on how to do it, promise resolve. So again, I'm creating a second asynchronous task which runs after the first one. I'm awaiting here both. I save it. I let the test rerun, and then we will hopefully see that the test is now again working. If it would be a little bit more complicated, then what I would have done is that I would have had said, I need to come up with a test suite. So I would say that's my sewer locator, calling it like this. And then I have my before each. And before we start with the before each, we also need to do something else. Namely, I'm defining here a clock. That's the clock, that's the term that we use in Jasmine. So that's the Jasmine clock. And then I say, before a test starts, I'm assigning the Jasmine clock to it, or I'm calling Jasmine clock. And then clock has a function which is called install, which means now Jasmine takes over control, is mocking all the timing functions of JavaScript, except of course the native promise. Then I have an after each, where I just say, okay, look, once the test has ended, I want to uninstall the clock just in case something happens or whatever. And then I have here the possibility to say clock, and now we see a known function again, a tick. So I could say here, I want to run all asynchronous functions right now, which are scheduled within 1 second if I want to do so. But as I said, we don't have here this use case, but if I would have, then this is what I would use in Jasmine. And in Jest, you would use the commands that you have seen in the slides. And the same is then also true for vtest, because again, vtest promises 100% Jest compatibility. Maybe what I also want to show you, because it was, at least to me, very confusing in the beginning, coming from fake async, knowing the power of the tick, that I said, you know what? Why do I actually need to do this kind of workarounds with await promise resolve? I have my tick. I can do whatever I want. So I'm just going to remove it and leave it as it is. Now, it looks very similar to what we had before with fake async. Sorry. If I now rerun this test, we see it's failing because the tick can't anyway control the promise. That's the problem. And that's why we see very often very strange constellations when it becomes really complicated, when we probably have multiple promises together, also maybe with a set timeout or something. Then you might see something like this, a promise which resolves, not like this, but a new promise resolve. Then we have here a set timeout. And I'm now putting this resolve into the timeout, which means I'm now really waiting until all the promises have been executed and would include this promise here into the timeout. And I would have waited. Then I would have said, okay, looks a little bit strange, but I'm now covering both promises and timeouts. Maybe that's the better approach. Not really. You see what's happening? Nothing. A timeout happens. And the reason why a timeout here is happening is the following. We are awaiting here a promise. The promise is waiting for the timeout. Now, who's waiting for the timeout? No one. We can't enforce it here because we have installed the clock. So the only way how we can trigger a timeout is to say clock tick. If I do it here, it's too late because the awaiting waits for it. There is a blocking that's like an atomic execution. If I do it here, it's too early. So what I would have to do, and this is a little bit strange, I would have to say here, I'm not awaiting the promise. I'm creating just a promise. Then I'm triggering the internal timeout. And after I've done that, then I can say I'm going to await the promise. And if I save it and rerun it, you see this time it's working. And this is a way how you can do it. We also know that the Angular team has reached out, because it's really complicated, to be honest, but the Angular team has reached out to the Jest and to the Jasmine projects and provided some new functions which will allow to work a little bit better when it comes to asynchronous tasks. But this is currently in the making, and for Jest, as far as I know, it has already been merged. Again, this is zoneless. If you're using Zone.js, you don't have to worry, it just works, but you should already start to prepare to think about the future, which is probably then zoneless itself. Good. Looking at the time, we are almost done. There is just one chapter which we have to cover, and that's the fakes. And I will not implement it, but I hope we still have some time that I show you what this is all about. I've also provided an example. But what are fakes? Fakes is like different explanations. Let's say it gives you those kind of, it is also a test double. So we are replacing the dependency, but in a way where we are completely decoupled from the way how it's implemented. I don't even need to know, for example, that the HTTP client post is called. I get instead another class, if there is a fake for it, which understands the use case, which understands exactly how the service is working. And I can then communicate with this class, which internally is then controlling the actual test double. That brings a lot of a much, much better developer experience, as we will see shortly. And because it's so powerful, the Angular framework already provides fakes for common things which we want to kind of replace. We have the HTTP testing controller, that's a fake. We have the router testing harness, where we can very easily, by not mocking anything of the routing system, still reuse router functionality in our test. And then we, of course, we also have the harnesses where Angular Material, for example, provides harnesses for all their components which they have. The downside is that you have to write those fakes. That's not so nice, but again, if you have a service like an HTTP client, which you use very often, you happily pay the price of an initial effort to write it once, and then you really gain a lot of benefits back. I also want to pay some credits to Younes, who has been advocating for fakes for many years. He's really great, and for 2 weeks before, he has actually also released an article where he goes into detail about the advantages and disadvantages, or actually only advantages about fakes. So I would heavily recommend to check this out. And I would like to show you, because coming from a real world use case, one thing where it's obvious what is the potential, what is the power of a fake. I am going to revert all of it, and I'm going to switch now to a branch which contains the same example, but where the sewer locator service is now using a resource, an HTTP resource, as you see here. It's just a refactoring again. There is a reason why I used the resource status, why I called it status, why I called this US value, because that's exactly the API that that resource is producing. Let's quickly go it through. So we are depending here on a location signal, which is set by set location. So from the perspective of the component, nothing changes. It's still calling set location. But internally, we are checking, is there a location actually set? If not, then there is no need to start an HTTP request. We have then here the definition of the URL. We have the method, we have the body as it used before, now in the form of the HTTP resource. We have our default value, something which I have also done before. And then we have here the pass function, which includes all the logic where we are coming from this response to the actual type that we are exposing here. So you see here in the end, we have still our current, the minimum distance, the nearest, and then also the source. Nothing has really changed to the outside. It's still the same thing. But if I now go to my sewer locator, then you see here, might look a little bit different, but let me quickly rerun the test. And I would now hope that the test is not working anymore. Unfortunately, it does, which should not be the case. Should find all sewers, HTTP client post and return value. That is strange. That is very strange, because I can assure you that this thing does not work like this anymore. It doesn't matter. It doesn't matter. I'm just going to show you the testing controller. But it would have been more educational if the test here is failing. Let me explain what this is all about. I am saying here that my HTTP client is always calling the method post, because this is what the resource here is also doing. It says post. For some reason, it could not be the case that the HTTP resource says, no, who's saying that I'm calling post? You just told me that the method is post, but the way I'm using the HTTP client, this is completely up to me. So, does somebody see an error? because was some highlight. So what could happen now is that the HTTP resource is using internally the request method. And that one would then be a problem because I'm expecting here that it's using the post. But then again, this is something where it's becoming a little bit difficult with a unit test, where I need to know a little bit about the implementation, about the way how it is used, whereas I actually don't want to do this. I only want to say, look, for me, the main important thing when I'm mocking the HTTP client is that a request goes out, probably with post, and I want to answer it. But I don't want to care how the HTTP client is used. And this is then where the fake is becomes so important. Because if I would not use the fake version, it's the resource solution there, then we see something is not working here with this test because it should not have worked. I also didn't flush the effects, which would be necessary. But yeah, you see here that I'm saying I'm using the original HTTP client. And then I say I want to use this fake, this HTTP testing controller. The testing controller can then be injected. That's a service which I only have available in the test. And this service allows me to indirectly define the behavior of the HTTP client without knowing how it's used. And the way how it works is that I'm saying here, and that's the key part here, I'm expecting, and I don't care if it's called post or request or something else. The main important thing is this is the request that should go out to that particular URL, and I want to answer it in whatever way the HTTP client is answering requests. I don't care. I'm just defining the behavior of the request. And then it's just like await, promise, resolve, as I've shown it before. But I hope you see here the difference. Before HTTP client post, I had to know what methods it provides. Whenever I changed the method via refactoring, it was now probably called post method, or because the component, the user used it differently, I would have had a problem in my test. And I would have had the problem not because the application is not working anymore, because my test just required to adapt to the needs and also to adapt to the changes of the implementation details, so to say. That's not the case with this fake anymore. Yes, somebody has to write this testing controller. That is not easy. But if I have 20 tests, that's more than enough that I see already the benefit of it. Tests are becoming much, much easier to write and also, of course, to read. So that's the big benefit of the fakes that you get over the mocks. Good. Yo. And from my side, that was it already. I just want to make a quick promotion. We also have a testing workshop, obviously. So, Brooke said this already. And other than that, I finished the end of my presentation of my workshop. And if there are now some questions, then I'm happy to answer them.
Yes, let's see. We had a question, another one from George. Will the promise trick that we saw also work with the v-test?
Yes, yes. But again, with v-test, you have the power of the fake timers. Exactly the same as it is in Jest. And there you have functions which do the promise trick internally. So you just need to say run all pending timers async. And then you await this one, and then it just works like the tick with the fake async. But not in Jasmine, unfortunately.
Here's another one that says, is it okay to test the value of a private variable?
Not really. No. So it's kind of the same pros and cons that I discussed before with unit and component testing. It's kind of an art to write a test where you distance yourself as far as possible from the implementation detail and still have the confidence that the test shows you that the application is working. And especially with private properties, you are very deep into the implementation details, and you should avoid it at all costs. So even if, for example, if you then also use, I don't know, ECMAScript privates, you might have other problems that it's probably not even possible technologically, or you need to come up with very bad things, which kind of do very bad things, like in Java, we had this. So no. Whenever you have something private, the way how it works is that the private is obviously there to be part of to fulfill the task of that service. Which means if my locator signal is private, then it is used by a public method, because otherwise it would be useless, then you can remove it. And you always test it indirectly. Or to be even precise, you don't test the private method, you always test the public API. Because if you're going to change again, if you're doing a refactoring of your private property and you are renaming it, or you're providing a different algorithm, and you say, but now it should still work, you can already start to rewrite your tests again. And this is not what you want. Tests should only fail if the functionality does not work, but not because you renamed a method from set location to set my address or something.
Got a good question from Michael. We're not gonna go too much over time here, but yeah, a lot of great discussions. It says, question, my inspiration for unit tests are often open source repos, including your toolkit. Do you have open source projects that you look at for real world unit test examples?
Yeah, I mean, Michael here is referring to a library. That is a different story. So if you're doing library development, you do have a lot of logic in your code. And then it really switches. Then you really want to have a lot of unit tests. So for example, if we're looking at NGRX, at the NGRX toolkit, or other libraries which I'm working on, you see that the majority there are unit tests. But again, a typical Angular application code does not look like a library. We don't have so much logic in it. Applications are always straightforward for a particular use case. There are not so many branches there, if conditions. In a library, this is very generic. A library don't know how it's going to be used. So there is a lot of logic in it. And that's why you need to apply there a lot of unit tests. For examples, yeah, I mean, I would say the popular open source projects, they all have very, very good unit tests. You can also check out NGRX. As I said before, there are a lot of unit tests there.